is a research scientist at the Australian Institute of Marine Science and is a true visionary in underwater bioacoustics. He's the co-founder of WILDLABS, the Global Library of Underwater Biological Sounds, and he helped create a groundbreaking open access platform designed to bring together underwater soundscape applications from across the globe. Miles is also a driving force behind WOPAM, the World Ocean Passive Acoustic Monitoring Day, a remarkable global effort that brings together researchers and enthusiasts to capture and celebrate the sounds of our oceans on a single unifying day. And we've had them speak at a Wild Labs event before, so if you want to find out more, go check out our YouTube channel and learn more about that project. But today he joins us to share his wealth of expertise in leading collaborative efforts that are shaping the future of underwater bioacoustics. And I love that the whole intro had a little soundtrack behind it. So thank you so much, Miles. And I'm going to hand over to you.
Well, oh God, what sound have you got? Thank you very much for that rather scary introduction. And I should say the library that we're talking about, we haven't actually implemented yet. We're still looking for funding to have the infrastructure built to it. I also wanted to thank Amandine and Erin for their talks, because there was a lot in there that I could relate to quite happily, and I'm sure everyone who's on the slides that I've got could relate to, because there's a lot of issues that have gone on that we kind of you're coming across the same problems that we've got. So yeah, presenting a global library of underwater sounds and WOPAM Day, which I think part of my favorite thing is coming up with acronyms. We've got quite a few collaborators that I've put on there, and just to acknowledge, hopefully, there we are, everyone that we have within the working group as of sort of April last year, and some of our funders. And from AIMS, we also acknowledge the traditional owners of the places where we work, both in Australia's land and sea country. We pay our respects to elders past, present and emerging, and their continuing culture, beliefs and spiritual relationships and connection to land and sea. And there are similar sentiments that go to the First Nations people of lands and seas where WILDLABS partners also conduct their research. So just as a little bit of background, this has all come realistically from the International Quiet Ocean Experiment, where we had a working group on the acoustic measurement of ocean biodiversity hotspots. We've also linked with people like Audrey Luby, who I saw is on as LinkedIn, and some leading members of other existing sound libraries. And this was basically out of a paper that we wrote back in 2020, where one of the lines was, to fully optimize passive acoustic monitoring in aquatic environments, we need to identify as many sources as possible. And I'm sure that resonates with quite a lot of people in the terrestrial field as well. So underwater acoustics is a bit behind terrestrial. It is a rapidly growing field. And just to show that, Kevin's done, and Amandine, thank you for mentioning Kevin at Worldwide Soundscapes. He's done a fantastic job collating a lot of deployments from the terrestrial and the aquatic world. Some of those aquatic ones that he's got a kind of a snapshot of people's deployments. What we wanted to do was go all the way back to 2000 and look at how things have developed in the last 20 odd years. So you go from a period back in the early 2000s where it was very restricted by technology. It was a few groups that had their own very specific equipment that they developed and could go out and deploy. As it's got into the last sort of 15 years or so, we've had more off-the-shelf units that have been developed, like say the sound traps from Ocean Instruments. Acoustics from the technology, from the data acquisition, the data storage has all expanded very, very quickly. And it's exploded in aquatic deployments, and will do again with hydromoths and the developments that are coming with them. So we've got a database that we ran through a working group with Ed Urban at the IQOE. That's currently, we've got about 10,000 odd metadata points for deployments in that database, and that's still expanding. So that just highlights the growth of PAM in the aquatic environment over the last couple of decades. And much like the terrestrial environment, biological sounds in the aquatic world evolve. There's revolution as you have any sort of disturbance. And so everything is growing. What we probably have more of in the underwater world is a much bigger number of unknown sounds, because it's so much harder for us to validate what is producing those sounds. And I use this as an example of that, in that Lauren Hawkins, who's a PhD student at Cornell University, has been through over 140 Australian data sets. They've been provided by about 7 institutes. That totals 150 to 100 years if you ran all of those recordings back to back. And just looking at fish choruses alone, she detected over 284 choruses of 80 different types. Almost all of those are unidentified fish choruses, although we know that a lot of those are going to be commercially, ecologically, or recreationally important species. So it just highlights the number of unknown types of sound that we've got with the aquatic environment. And again, similar to terrestrial, there's a growing interest in aquatic biological sounds, whether or not that's citizen scientists, musicians, artists, the general public. We use Cosmo Sheldrake as an example, who has recently done an album through sampling marine fauna sounds. And the example that I have for artists is this multimedia, where I gave some recordings of a coral soundscape to an artist who set that up with some physically wearable art that she had. So you can see there is, it's actually example coral, which if you use your iPad and link into the QR code, you get the music of a healthy sounding coral reef that as it gets louder with the day, it lights up and you have all of the coral coming out. And it's a wonderfully immersive technique. Another immersive one, literally from an Austrian artist who got me to send him a recording where he played it underwater. People could go and look at the art, stick their head in a bucket and listen to the sound being played through the water in the bucket, which probably made the gallery really quite wet. But again, underwater world, we've got management applications for species detection. Ecoacoustics is becoming more used. We have data sharing, single access points, and functionality and analysis tools that we want to develop. Now, Erin made the point about having a potential for a single point of access or a single centralized hub where you can have data in it. For some context, the underwater data sets that we've got can range from between a few gigabytes to a single deployment being 80 terabytes. So the volume of data that we're working with is huge. And people like the National Center for Environmental Information in the US are trying to deal with all the deployments that NOAA might make and how they can store that data. And they have things like 50 petabytes allocated to that. The other point that I wanted to make is that underwater sound libraries aren't a new concept. Ranth did a publication in '96. Fish tried to get a library for all of her sounds back in the 70s. So it's not a new concept that we were putting together, but what we did propose was to have an integrated sound library and associated analysis and information tools. But we also realized that there was existing libraries. We didn't want to supplant those, but to enhance them. So just to put up there our vision statement and mission statement, the point there being that GLUBS develops and merges novel technologies with existing bioacoustics resources. And what we wanted to look at and how to do it was to create an umbrella application programming interface, so an API, not to supplant existing programs, but to link external applications where possible and help build functionality in external applications. And where that was lacking, hopefully we can build internal programs to help build that up and link them together. So in talking about this, and one of the points that we wanted to get across is that we've done this as hopefully in as a co-designed way as we can. We talked to 85 aquatic acousticians across 20 countries to look at what they felt should be in this sort of platform. And as you can see on the right there, we had people from freshwater, marine, brackish environments, everyone that was new to research to those that wouldn't disclose how old they were. So we had a range of people to talk to. We gave them a list of questions to discuss, and we also wanted to try and prioritize what they felt was the most needed applications and how they could be linked together. So I've just put up there, there's probably not time to read it all, but just to identify that even though we know there's reference libraries out there, getting a big reference library of known sounds for our research field was clearly the top one. And for people with the Bioacoustics Forum, so like the Slack Exchange, it was considered to be important, but the point that people made there is that there was already a couple of those in existence. So just a couple of things that we've actually compiled while we've been going through this process. I think Amandine mentioned that there was a list of libraries that she put up a link to. We've done a compilation of underwater sound repositories, and within that, we've got a list of other analytical tools and libraries as well in that publication that we've got. The other thing that we've produced, which has been led by Audrey, which was a collaboration in Fish Sounds.NET. And what I should say is that Fish Sounds is a fantastic library for calls of fish. We have created a database that's gone into the World Registry of Marine Species of sonifery for 36,000 species of marine mammals. So that's categorized as to whether they're known to produce sound, likely to produce sound, unlikely to produce sound. And you can see a little graph there of where those species fall in terms of whether or not we know or think they will produce sound. The other thing that I wanted to bring to your attention is WOPAM Day. A quick synopsis of it is that it was to be a global celebration of aquatic PAM, that we wanted to bring everyone together on World Oceans Day. And we thought that was a nice day to focus on. And much like Amandine mentioned, it's been done without having any funding, is how we started it. But in contrast to you having an urgent need to get things out and to get people involved, what we needed to do was recognize that there were people that already had deployments going on. And rather than get them to put out new things, to have them share data from that one particular day, because as I said, these are huge data sets in terms of their volume. So just having 1 or 2 days is very useful. We've done it for 2 years now. We're still collating data from 2023 because some of the deployments go for 12 months. We have over 100 institutes from 2024, over 200 researchers that were willing to share data from over 400 sites. One thing I'll play just at the end is an example of the soundtracks that can get produced by taking those sounds and bring them together to make a musical track. And what we hope is that this will give us a snapshot of the world's aquatic soundscapes. And next year, we hope for that to become citizen scientists to be involved. And one of the future developments would really be those low-cost hydrophone systems to make it more accessible. The stalling points that we've had there is data agreements in terms of liability and licensing for data. Obviously, working in an aquatic environment, if we're leading it, I've got slightly more concerns about people's safety and deploying things into a water environment. But there are hurdles that we're getting through there. Moving that into the future, research institutes can pick up data in a range of aquatic systems, but we tend to be focused more on nearshore. Citizen scientists can get to nearshore and freshwater systems, but to get that deep water coverage, there's the Argo program. If you're not aware of these are Argo floats, several thousands of them that are constantly floating around the world's ocean picking up data. There's been talk about connecting hydrophones to these, potentially to be able to just get sound level products, but in an ideal world, being able to get raw data that could be shared to look at some of those soundscapes themselves from that day, from June 8th. And then leading into the future, we've got fiber optics, distributed acoustic sensing, and all of the information that will be able to bring up. So just in summary there, we're still going through the process of designing a platform because we're trying to do it in a collaborative co-design way. And we started again with no funding, which what we need to do is get the funding to build that infrastructure. We've got between the groups multiple reference libraries on different species of aquatic fauna. And through the process, we've managed to develop a couple of tools that we hope will be useful. But again, much like everyone, it's all about embracing the aspects and the interests in PAM and hopefully bringing in citizen scientists, which has a very scary data volume side to it for us. And I've mentioned that, the data agreement side of things. So if I have any time left, and if this sounds played well, do I? You can nod, I can see you, Steph. I'll hit
Look,
play on
you
them.
promised to make it interactive, so yes, you won me over.
Okay. So this is a track that was made by Alejandro Bernal. He used data from WOPAM 2023, and all of the sounds within this are marine fauna. He's tweaked them slightly. All right, I'll stop that there, otherwise it'll go for ages. Okay.
So if I just got quite excited about that ending, because we've been looking at all of the music as part of the preparation. We spent quite a bit of time looking at all of the music created with bioacoustics sound. So I'm so glad you finished there. But I'm quite conscious of the time, so I'm just going to throw to. There were a couple of questions that were really interesting that I wanted to throw to. Bob, did you want to jump in with yours?
Happy to, yeah. So I was just wondering, you mentioned you were building all these tools of analyses on this platform. I couldn't completely follow everything, so I might misrepresent what you said. But are you also planning to like make APIs, or maybe they already exist, to export the data of these analyses to be used in other platforms, so that the stuff actually goes in but also goes out again?
So yeah, no, it hasn't been built
to us,
yet.
for instance, to Xenocanto, that I'm going to talk about in a second, or other places. I mean, there are plenty of great platforms these days.
So yeah, I mean, the idea would be to link with the Worldwide Soundscapes project itself. So yeah, if I've understood you correctly, we would like to be able to get into other data repositories, allow users to be able to analyze some of that data with specific detection algorithms, which have either been developed on a platform that we would have, or their own that they could be able to share. So it would be interactive to be able to go in and out of different APIs. But yeah, we're still in the process of designing how that would work.
Okay, Vanessa, do you want to ask your question?
Yeah, sure. Thank you. I was wondering, like you mentioned a huge amount of data, and I was wondering what are the possibilities and challenges for developing compression and reconstruction techniques for bioacoustic data to enhance storage capabilities without losing any kind of information.
Sorry, I constantly get the Mickey taken at me for having a large number of hard drives on my desk. Yeah, compression, not only compression, but subsampling. So we go through the process of looking at how well the subsampling can affect the outputs that we get, and whether or not, say, you can decimate your data collection from continuous to 1 minute every half hour, every 15 minutes, and whether or not it's just worth saving that smaller amount of data. Unfortunately, it all seems to be representative on what your objectives are and what species you're targeting. In terms of compression, I don't really have much experience in that in terms of being able to put it up on a much larger database. Everything that I have stays uncompressed because it just takes me time to compress and take it apart again every time I want to use it. So I work with a large number of hard drives and leave it uncompressed.
Okay, wonderful. Thank you so much, Miles. I'm going to bring you back for the discussion in a few minutes.